Consider the following sequence of digits, 0, 2, 0, 4. A person claims that all the ones in the sequence are to the left of all the zeros in the sequence. Is this true? Justify your answer. Hint, write the claim formally and write the formal negation for it. Is the negation true or false? So at face value, this question might seem confusing because there are no ones in the sequence. So how can we make claims about all the ones in the sequence if there aren't any? And the weird truth is that based on the rules of logic, if we look at the negation of this, we can clearly see that the negation of this claim will be false. And if you negate a false claim, then you end up with a true claim. So we'll end up proving this is true by showing that the negation is false. So first we're going to show what we need to negate. So all the ones in the sequence are to the left of all the zeros in the sequence. If we negate this, we're negating a universally quantified statement, which means that this negation will be existentially quantified. So what's being quantified in this statement? Specifically, all the ones, which means that the negation is going to be there is a 1 in the sequence, 0, 2, 0, 4, and next we need to negate the claim that's being made, which is that all the ones in the sequence are to the left of all the zeros in the sequence. So there is a 1 in the sequence 0, 2, 0, 4. Next we need to negate the claim that's being made about all the ones, which is that the ones in the sequence are to the left of all the zeros in the sequence. So we would say in the negation that there is a 1 in the sequence that is not to the left of all the zeros in the sequence. So this is the negation. So now let's ask ourselves, is the negation true or false? Is it true that there is a 1 in the sequence that is not to the left of all the zeros in the sequence? The answer is no, because an existential claim requires the existence of the object being quantified, whereas a universal quantifier does not necessitate the existence of what's being quantified, but rather with a universal quantifier, we're identifying a property of all the ones, regardless of whether or not those ones even exist. So the existential claim requires the existence of the thing being quantified, which is the 1, and there is no 1 in the sequence. So to say that there is a 1 in the sequence that satisfies this property would have to be false. But that means the original statement is true because the negation of a false statement must be a true statement, according to the law of non-contradiction. So that means all the ones in the sequence are to the left of all the zeros in the sequence. And you might say, but there are no ones, so how can it be true that all the ones in the sequence satisfy this property? It's because universally quantified objects don't necessarily need to exist in order for the universally quantified statement to be true. The existence of an object requires an existential claim about that object. We will see something like this again in the future when we talk about properties of the empty set. Thanks everyone, and I'll see you in the next video.